Like event bubbling?
Oh no. So event bubbling. Okay, that's a bit of a blast from the past. So that's a specifically JavaScript thing when it comes to dealing with the DOM. So the two main sorting types we're talking about here are what's called bubble sorting and insertion sorting. And those are two classic ways of sorting an unordered list or array into an ordered list or array. They're two very simple sort of iterative types. And I believe, so you guys start talking about complexity today, right?
Mm-hmm.
Yeah, so these are both ways, if I am not mistaken, of doing ON squared. So we can look at, did anyone write a method for either? If they want to share?
For which part?
Either way, if anyone figured out a way to bubble sort or insertion sort any of the solutions.
Okay, I tried to read about it, but I didn't see a lot of difference. Did it
okay
on my way. I have to just a moment.
That's okay. Why don't I show? I'll show a quick example before I put in the new graph of today. And this is again using the power of debug, which is wonderful. So we have our two different. This is a method for insertion sorting, and this is for bubble sorting. So I'm actually just going to run these and show you sort of how it works. Oh, of course, I shouldn't have put the breakpoint at the end. Sorry. Okay, so at this point, I can show, I have a new list that I create. And I realized looking into this later on that there are a couple different ways of doing an insertion sort. For what I'm doing here, I am creating a new list entirely. I'm kind of copying it over. So I have my original list, which is just list. It has the numbers 1, 2, 7, 13, 4, 2, 6. As you can see in the debug here. And what I want to do is iterate over that entire list. So I'm going to do a for each over the list. First one, I'm just going to stick into my copy array. So I'm just going to add list.first. So we do our first iteration, and our new list now has 1. Next time I know that there is something in the list, so I'm going to look to the next one. And what I want to do is I want to see if this element inside of this list is, sorry, I first want to make sure that the index doesn't go over the length of the list. And I also want to see if the item in my new list that I'm currently at, I'm iterating over, is less than the item that I currently have from the old list. So my new list at index 1, or at index 0, is 1. And the element that I grabbed from the second index in the original list is 2. So I know that this is less. So I'm going to push the index up. So now my index is 1, and I'm going to insert 2 into it. So let's actually go to an example where that does happen. Okay, so now at this point I have, I'm going to be on number 7. Okay, 13, So I realize now that this is not a great way of explaining things. Okay, so I've iterated a few times through the list, and now I'm at 4. My new list goes 1, 2, 7, 13. So I'm going to iterate. I'm going to see is the item at index 0 greater than 4? No, it isn't. So we increase. What about the item at index 1? 2 is not greater, so we're going to iterate over again. And then we find that it is at 2, or at index 2. 7 is greater than 4. So I'm actually going to insert it into index 2. And that's basically how an insertion sort works. So I'm gradually inserting numbers from the original list into a new list. And I'm finding where they fit before I put them in the list. So when I'm looking at 4, I see, okay, 4 is not less than 1, 4 is not less than 2, 4 is less than 7, so I'm going to put it before 7. And that's a fairly efficient way of doing things. It is O(n) squared because we're iterating twice, so we're doing a nested loop, because I have to do a while loop inside of this for each. But I'm placing the items in the correct order as I'm creating the new list. And that's why that tends to be fairly efficient. So I'm not sure if that makes, if I could just do like a little diagram here. So if I have 1, 2, 5, 4, 7, 3, 7. So for my first one, I look at 1, I see there's no 1 in here. I look at 2, I see the 2 comes after 1. I look at 5, I see that 5 comes after 2. I look at 3, I see that 3 comes after both 1 and 2, so I insert it in afterwards. And then I find that 7 comes after 1, 2, 3, 5, 7. Realize that was not a very straightforward explanation. So does anyone want to go over that again, or does anyone want to kind of see if they can explain it?
No, I think that makes sense. An insertion sort inserts things in a sorted order.
That's right.
Right?
That's actually one method that I have for doing it. I know other people have other methods where they will, I think the actual, like a true insertion sort does not create a new list. It will actually, if the list is unordered, so it'll be like 2, 1. It will take the first one, find that 2 is greater than 1 but less than 6, so it'll put it there. It'll find that everything is in order until it realizes that, what is it? 3 is not greater than 7, so it'll put it back. So a true insertion sort will not create a new list like that. I honestly did not know that that was a different way of doing it until I looked it up online. So this is kind of my method that I use when I create 2 lists. But again, that's O(n) squared because we do a nested loop here. A bubble sort is, it's called a bubble sort because the greatest values tend to bubble to the top, supposedly, or some people will call it a sinking sort, where the lower values will sink to the bottom. So let's actually add this. Yeah. And a bubble sort is notoriously inefficient because it is much like an insertion sort. This is O(n) squared because a bubble sort needs a nested loop. But basically what a bubble sort does is it does a sequence of, it will do a sequence of runs over this list. And each time it finds something in the wrong order, it will switch places. So if it sees that 7 and 2 is greater than, 2 is less than 7, so we'll switch places between 7 and 2. You'll then find that 4 is actually less than 13, so it'll put 4 in front of 13. We'll find that 2 is less than 13, so it'll put 2 in front of 13. And then it'll find that 6 is less than 13, so it'll put 6 in front of 13. So it will do that once, and then loop back over and find, oh, so 7 is greater than 4. And it keeps on doing that until it is finished. Basically, until we decide that things are sorted, if we have to iterate over it a number of times. So I have to create this Boolean to make sure that if I don't switch any positions, if no positions are switched, and then I do a, why should I use a while loop here? Why not a for loop? Any guesses?
Because you don't know what's the steps, what's the length of the for.
Right. I don't know how many steps this is going to take. So that's why I use a while loop. And that's a pretty, like, as we get into more of these algorithms, just to remember that if you don't know how many steps something is going to take, use a while loop. I can use a for loop because I know how many integers there are in this list. So I want to make sure that when I hit the list count -1, so when I'm 2 away from the end, I want to increase. And if this is just if I find that if the first item in the list is less than the second, because I actually want to, I'm doing this in reverse order. Oh, sorry, that's not correct. So basically, if I find that an item in the list is greater than the one that follows it, I switch them. And then I say that the sorting is false because we had to do a switch. And we just do this over and over and over again until it finishes. So it's O(n) squared, like the insertion sort, because it's a nested loop. But unlike an insertion sort, which has to go exactly once over its list, a bubble sort might go a million times. So it's same complexity, much less efficient, because I have to loop over the array possibly dozens of times before it finishes. So that's one to kind of keep in mind. If somebody asks you the difference between, like, what's the difference between a bubble sort and an insertion sort? They're two very basic sorting methods. Obviously, there are more sophisticated methods out there, which we're going to get into later. Yeah, that's about it for the last lab. Was there any part of the last lab that anyone wanted to ask questions about before we move into the new one? Hi. Sorry. Okay.
What is the purpose of that method, any?
Of bubble sorting?
No, in the other side.
Oh, insertion sorting.
Yeah.
It's really just it's a pretty straightforward, and also it's a decent way to get a list sorted into order, because as you'll see later on, so we are going to talk about methods later on about searching for indexes of items in an array, and it is much, much faster to search a sorted array than it is to search an unsorted array.
Can you share with us these two types?
Sure, yeah, I can post that up.
Okay, thanks.
I'll put it in a Google Doc afterwards, and I will send it to everybody so you can look at the difference. I might add a third one later on of a more traditional insertion sort that doesn't use two lists. But yeah, I'll definitely put up the two. Just try to remember that insertion sorting is typically better. So we're on lab 5 dictionaries. Okay. Just going to give the link. Okay. Where's my controls? Oh, there. Okay, so I'm just going to post in chat the link to the new lab. So as I mentioned, this one's going to be on dictionaries. And this is an example that I tend to use quite a bit of a car park. So it's just going to have a simple collection of, I'm just going to put in a little example right now. Okay. So this is, again, us kind of moving a little bit closer to seeing how a database functions. I like dictionaries because they can be used kind of similarly to databases, where we just want to collect. By collecting a series of key object pairs, we can start to resemble how a database table might look, where we're typically using IDs instead. But basically what we just want to do here is build a small system that consists of numbers. So remember, key value pairs, where the key is the stall spot and value of that pair is the license plate. And we just have a couple of methods that we want to create on that. So you're going to be writing some algorithms for initializing one, for finding empty spots, for finding the proper values, the proper keys. So that should take, I think that'll take about 50 minutes. Of course, I'll be here the entire time. I'll check in at around 25 minutes from now to see how everyone's doing, as well as closer to the end of the lab.